I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University.
I'm Samrat Amin. I'm the operations director for the CEC Corps at Arizona State University.
So we're here today to introduce some sensors that Samrat has designed that that can be used in a lot of laboratory settings for thermodynamic applications. And when we think of looking at thermodynamics or measuring some types of calorimetry, et cetera, what we think of measuring is temperature. But if we think of just general thermodynamic parameters, like if you're doing PDV work, pressure volume work, you want to measure, say, for example, the pressure of something. When you're looking at entropy temperature, it's usually measuring temperature, et cetera. But in general, what we think of now is kind of as having a smartphone, having a lot of sensors on it now, temperature sensors to how hot things are getting in your computers, fans, et cetera. But having sensors for light, having sensors for humidity, for different environmental conditions. And he's been designing a sensor that is cheap, portable, easy to use, and probably what I would say most importantly is something where the data gets streamed directly to a cloud service or directly to something you can access via any web connection or any internet connection. And this makes it where now we can collect this data from anywhere and be able to access it, get it, download it, analyze it, do things with it, et cetera. So you can use it from things as simple as just monitoring environmental conditions in a room to potentially even using it to collect data for a laboratory or some type of experiment, et cetera. So with that, I want to delve into kind of where you are now on some of this design and what is thought of in the future and what you can do. So starting with the board you have in your hand, this is an ICU designed or?
Yeah, so this is a board we made specifically for monitoring various lab parameters. So in the lab, we're interested in knowing the temperatures, humidities, light levels, all that.
So if we can just summarize on the current board you have, what are the sensors?
Yeah, so this board, for example, has a temperature and humidity sensor down here. It has a thermocouple sensor. It has a
temperature and humidity are on one sensor, but then you have a thermocouple, which is also temperature.
Yeah, it's separate.
On it. So you have two temperature ones. You have a humidity. You have a light level.
Yeah.
And it's just a photodiode, or?
Yeah, pretty much.
And then you have what else?
And there's a magnetic sensor.
And it's measuring both the direction or just the amplitude?
This one is not directional, but you can get 3-axis magnetic sensors.
Yeah, like
as
what
well,
you find on cell phones now, right? So, and all of those collect data at what frequency or how often?
Well, these currently collected at about once a minute, just because that's all we need. But the board is actually capable of collecting it, less than millisecond range, or tens of millisecond range. So it kind of depends on your application, right? How fast you need to collect the data, and it partly depends on how you're streaming the data, storing it as well, because the other side, your database or wherever you're storing it, needs to handle that data rate. And
so is this a board that you're this isn't one you're just buying off the shelf somewhere.
Nope, it's custom designed.
Yeah, so you're designing and you could add other sensors to it.
Absolutely.
Also, from what I can see of that board, it looks like there are inputs where you could take an external, so for example, an external thermocouple and plug it into that, or at least wire it into that.
Right, yeah.
So how many external things could this handle?
Well, so this one, it's made to handle one external thermocouple input, but if you look on the back of it, there's a bunch of pins broken out. So what I typically like to do when I do board designs is I leave a bunch of extra pins, especially communication pins for certain buses. So when you make electronics, it's common to use either an I2C bus or an SPI bus, which most of these sensors will end up working on. So as long as you break out pins for that, you can just hook them up externally and read whatever other sensors you want as well.
Okay, so this is the one, and how? I mean, just to get into what is the general cost of one of these?
Well, this particular board is probably about $20.
Okay.
raw components, and we're talking about buying them at small volumes as well. So
Right. So it would be cheaper if you did a lot of them, but in kind of the small. And then this is all the sensors, and but this now has to communicate with what to because the data it's not stored locally on there?
Well, it can. So you actually have some built-in memory here in the microprocessor itself. So if you're only trying to do something that's short-term, you only want a few data points, that sort of thing, you can just dump it directly onto the microcontroller, read it out later at a computer. But
it doesn't have, I think of it, to make an analogy which most people, or a lot of people have seen now, like now it's gotten really popular to get these kind of Wi-Fi cameras and stuff like that. Usually the kind of two options is that it streams, it doesn't have built-in memory and it streams it somewhere else, the video, or, you use like micro or just normal SD cards and it collects it locally, and a lot of them do both, right?
Yeah. And this one does both as well. So on this board, we have built-in places where you can put an SD card and log it directly to that. Or
so then you could just come and grab that SD card, it would have all the data.
Exactly.
Does it just inherently stored as kind of ASCII XY, or
it's completely programmable, right? So you have complete control over what kind of data structure you're outputting there.
So, but what you do right now is you have it where it's not stored locally. It basically streams it.
Exactly.
And in fact, we have the website up here. Where you have a website that interfaces to where the data is in a sense streamed, and you have a website designed where you can plot that streamed data fairly simply.
So if you take a close look at this microcontroller here, you can notice this little green part up here. That's actually the antenna for the Wi-Fi on this microcontroller. So these days you can buy various microcontrollers with Wi-Fi built in or Bluetooth built in or both even. So it gives you a lot of options for streaming data. So this one in particular, it sends data up directly to a server that we have running remotely, and it sends it at a certain interval that's been programmed into this device. So looking at the computer here.
So just to stop for a second there, you had to tell, most of them have interfaces that say like, okay, this has a Wi-Fi, set it up, right?
Yeah.
And you have to set it. This one, in a sense, is at a more, is not. It's not like you've built an interface to do that type of set. You could.
Not yet. Yeah.
But right now you're having to do it kind of directly, like plug that thing in.
You actually program the Wi-Fi credentials and update intervals, all that stuff directly onto the program or the flash memory of the microcontroller at this point. But once you have it set up, it's not that hard or difficult to go in here and make a web interface where you have all those parameters here, and you can actually flash them back onto the device itself.
Yeah, so you could change it if you move it on Wi-Fi networks, et cetera, so that it re-establishes a connection to some new Wi-Fi network, et cetera. Okay, and so then once you've established a Wi-Fi connection, as soon as you've done that, like you said, you have parameters where it sends data packets every so often, and right now you have it set at about a minute interval?
Yeah, roughly. It depends on which sensor we're looking at and what we care about. But
okay, so one that is running this sensor, the one we're looking at right now is pressure, not temperature. And so maybe you could quickly show us that you can have a similar type board, so it still has the same Wi-Fi antenna, still has humidity, temperature, everything. But now you instead of an external thermocouple, you can hook up this as an external device, and this is a strain gauge?
It's a strain type of pressure gauge. So you can buy different types. There's membranes and whatnot. But the nice thing about using an external one is you can actually buy these for various pressure ranges. So if you only care about looking at something below 25 psi, you can buy that and use it with the same resolution, or better resolution actually.
Right.
You use it with the same range, voltage range. So this one that I have in my hand is a 3000 psi.
So just like with thermocouples, you usually use different in a sense, different alloys of metals that cover different temperature ranges with different resolutions or changes in voltage. This, like you said, you use different, membranes versus strain gauges to kind of cover either high or low pressures, et cetera.
Yeah.
And so this one is kind of strain, is kind of what I think of as, tank, right? Like this is meant to handle tank cylinders and
Yeah,
kind of what
exactly.
you would say not real ultra high pressure, but medium pressure ranges.
Right. Most lab things that you use will fall into this range.
Like
So
a couple thousand psi. Right?
And the resolution is actually very much dictated by the analog to digital converter that you use on this board. So on this board here, actually, I have a separate analog to digital converter. So the ones that are built into the microprocessor are typically 10 or 12 bits, so they don't give you ultra high resolution, but these days it's pretty easy to get 16, 18, 24, 32-bit ADCs that you can put right onto the board and get much better resolution out of this. So even though it has a 0 to 3000 PSI range, I mean, you can still get about 0.1 PSI resolution out of this thing from this board.
So, so what you've done here is, for this specific application, and people often forget pressure is quite a useful variable. In fact, most people often think of, temperature is what you get out of the environment, and people have a sense for temperature and humidity, but almost every time you listen to a weather report, you also get something about pressure, right? Sure. Like, I mean, and it's what they, highs and low, pressure systems, et cetera. I mean, like, this helps dictate, a lot of forecasting of weather, by what pressure you're at. You can often say what altitude, you're at, et cetera. So, there's a lot of things. And then, to break it back into chemistry, we use, in chemistry a lot like vapor pressure, et cetera, to get a lot of, at some fundamental, when you start introducing ideal gases, I mean, one of the first things you think of is, pressure as a variable. So, so you can do anything from, looking at environmental things that are very important with pressure, making connections to altitude, other, important variables, et cetera, to measuring real chemical systems. The amount of pressure is often directly proportional to the amount of concentration in the gas phase, right? Partial pressures of gases and stuff. But here, I think of it as a very practical one. In fact, the one I'm most interested in as kind of a lab manager is we often have pressure tanks everywhere. Yeah. And this hooks directly up to it, and you're only a step away when this is fairly cheap to add to your pressure cylinder to almost do like I do at home. Right now at home, if my door opens or somebody comes or rings the doorbell, it'll notify me with a text message on my phone, and I could let, kind of some of the newer digital wave of Internet of Things. This kind of brings the Internet of Things to the lab, right?
Yeah,
because
absolutely. Now
I could have all 20 gas cylinders, some that are running instruments and purging FTIRs and doing whatever. Yep. I could have them all send me notifications when they're running low and not getting empty, or if there's any type of big fluctuations, et cetera. So
that's exactly why we have these hooked up at the Magnetic Resonance Center. The green data that you see here is our air compressed.
Is this in, what's the y-axis of this?
That's
the X
PSI.
is time,
Yeah.
right? So as a function of time, and what, just so I get a sense, like what is this overall time interval? Is this days?
It's looking at over today, So you can basically, right now, the system is very much in the works, but you can just pull up data from various days.
But you're getting, every minute you're getting a new data point. So looking at the one that's not as jagged here at the, but so I mean, you're sitting between 85 and 90 PSI in that, whatever that's hooked up to.
Right.
And I think of that as being kind of low pressure. So this isn't hooked up to like a big tank cylinder, which is often in the thousands of PSI. This is like air, coming out of a basic compressor.
Yeah, exactly. So this is actually in the building. These are building gases that we use to run our instruments. So
one is one type of gas and one is another? Or?
The orange one that you're looking at is the nitrogen line, which ends up running
So is that dry
our DSC.
nitrogen off of a Dewar tank? Or
yeah.
Okay.
Yeah. And I believe that comes from engineering, actually. So,
and then is the other one just compressed air?
Yeah, and that's building compressed air, which for us is useful for
so you can even,
various instruments.
Like it looks like it's cycling, it's cycling, so that is the compressor cycling on
Yeah,
and off,
exactly. Or? So, with most things with frequency, you want to sample at, at least twice the
Nyquist
yeah, exactly.
formula.
So I don't know if we're actually doing that in this case or
or not. But you can definitely tell there's a
Yeah.
cyclic, and it's probably the motor
Right.
going on and off that causes a fluctuation in the pressure.
I mean, our interest wasn't in knowing the frequency there, so we just want to know the pressure.
But at the same
fluctuations.
time, if you needed really steady pressure, you would know you would need to ballast that line, or you would need to do things to it, et cetera, by having that type of resolution.
Absolutely. And I mean, this really interfaces with a lot of our instruments. So, for example, a solids NMR instrument where we're spinning rotors using compressed air, if this goes down, we have a problem.
So this
we can
interfaces
have
with
this-
the NMR instruments, but also in thermodynamics or in undergrad labs, we often use DSC, or differential skinning calorimeter, and this hooks directly to the nitrogen and stuff for that as well. So it's not just NMR. I mean, you use gas cylinders or compressed air stuff in all sorts of chemistry applications and instrument, either flow gases or like you said, purge gases or something like that. Usually it's almost always a control of temperature, right? Like some gas flow over samples, et cetera.
Exactly.
So this shows pressure. Your initial one didn't have a pressure one on it, and that's external. Can you pull up one that shows kind of your temperature, humidity, or?
Sure. Let's pull up this one here.
So this is just one of these sensors that you have just kind of sitting on the wall at the entrance of the magnetic resonance center.
Exactly, yeah.
Okay.
So this just allows us to view what's going on in the lab.
And so it's how much, I'm surprised the light doesn't fluctuate on and off a lot more.
It should. Maybe someone didn't turn off the lights last night in the lab, so these are things we can monitor.
But it kind of gives you an indication. And then the temperature in the room, the stability of the temperature, the humidity fluctuates significantly. I'm kind of surprised. I guess it's not obvious to me what causes that cyclic over a day humidity. And then are there any other, and then the magnetic, which better be pretty stable.
Yeah, right.
Okay, well that's very interesting. Thanks for answering all my questions about this, and hopefully, this will be useful to anyone that wants a general introduction to this, because you're designing these in such a way that they can be used for, standard environmental probing or sensors to, potentially even use in some type of data collection for a lot of different things, right?
Yeah. Yeah, and it's custom built, right? So you can apply it to anything you want. If you have another need for it, you just slightly modify the design and reprogram it for whatever you need.
Thank you very much.
Sure.